Let me use this example as an illustration on how to work out the planning in the 3D problem. A 3D problem usually is the more complicated one. Most likely the answer will not be reached in one single step. So we have to break down the whole solution process into several stages and how we find out the connection between stages. So for example, this one, right? First of all, I would put down the lengths into the diagram, right? So we have CQ equals to 9. So this red part is 9 cm. All right. We have QH is 15. So this is QH will be 15. I will put down 15 as the blue part. All right. And moreover, we also have the green part and the orange part. So the green part will be this one. It is 16. All right. Because it is a rectangular block, so not just this one is 16, but all the lines here, they are also 16. All the green lines here, right, they are also 16. And also we have 12. 12 is in orange, all right. This is 12, but once again, this is a rectangular block. So so all the corresponding lengths in orange, they are also 12. All right. These lengths, all of them, they are 12 units. Okay. Now let's see. At the end, we want to find angle sine PFQ. So we want to find this angle. All right. So now it depends on the focus triangle. I guess the focus triangle will be triangle FPQ, right? That is the most obvious way to get the angle. So let me put them in yellow, pink, and gray. All right. Okay. So this is it. All right. Now there are many colors on the diagram, right? But after all, we have the focus triangle will be this one. All right, we have the triangle PQF, right, like this. All right, we want to find this angle. So now, in the focus triangle, we need 3 pieces of information to find the angle. All right, and the given information on this question is all about lengths. So I guess I would adopt the SSS, the triple S approach. I will find out the length of the pink line, the yellow line, and the gray line, all right, using the cosine formula triple S approach. But then if you use the cosine formula, we'll only get the answer for cosine triangle PFQ, right? But once you have the cosine angle, we can switch back to the sine angle. Using sine square minus cosine square equals sine square plus cosine square equals to 1. We can do that, right? So first of all, what we need to do now is to find the 3 lengths: the pink one, the blue one, the yellow one, and the gray one. All right. So we can use various Pythagoras theorem to help us get that. All right. So first of all, the gray one, right? The gray one, we can do it with a Pythagoras theorem from the purple part and the red part, right? It is a Pythagoras theorem between the purple and the red. We can set up a triangle like this. We have the purple one, we have the red one, all right? And the gray line will be here. All right, if you want the vertices, that would be vertex C, Q, and P. So how much do we know about this? We know that the red one is 9, but we have little idea about the purple one, right? But fortunately, we know that on the ground level, the purple one is once again another Pythagoras theorem between the orange and the green. All right. When you want to understand this, my solution, the use of color is very important, right? So it's like the whole purple one. The whole purple one goes all the way to C, AC, all right? But P is the midpoint, so it is twice of the purple line. All right, so you have 12, you have 16, all right? Once again, another Pythagoras theorem. So using the Pythagoras theorem, we can get the purple line. The purple line is 20, all right? So half of it will be 10. So now we have the first solution. The first break will be the gray line, will be the square root of 181. All right, so that's how we obtain the gray line, the square root of 181. All right. Now, by similar token, we can work out the pink one and the yellow one, right? For the pink one, for example, if you look at the purple line FH is just the same as the purple line AC. right? Because it is a rectangular block, so it is symmetric. So on the top you have the purple, the blue, and what else? And the pink. All right. I prefer to use color to construct my thinking rather than labels like F, H, Q. I hate using this ABC or F, H, Q or whatnot. Right? I prefer to think in terms of color. But once again, you may develop your own style. All right. But in my calculation, I prefer to think in terms of color. So we have the purple one goes to 20. Half of it will be 10. All right. And that is a 15. Now this once again is a right angle. Right, it's a right angle everywhere on this diagram. These are all right angles. All right. So 20 and 15, the Pythagoras theorem give us 25. All right. So the pink line goes to 25. So we have this 25. All right. We're almost done. We just need the yellow. All right. Now the yellow one will be this long line. All right. The yellow one, and the vertical line will be a combination of red and blue. Right, it's a blue 15 and then a red 9. Alright, so that goes this part. And then the bottom, once again, is the same purple. The purple one is 10, alright, half of the diagonal. And this is 15 plus 9, it goes to 24. Alright, so the yellow line will be 26. Alright, the yellow line goes to 26. Now we have almost everything. Alright, we use a large numbers of Pythagoras theorem. We obtain the orange line, we obtain the purple line, and then we have the gray line, the pink, and the yellow line, right? According to all these right angle triangles. So now we have all three sides of triangle PFQ. We can invoke cosine triple S cosine formula to do that, right? So we have cosine angle PFQ equals to the yellow square plus the pink square, 25 square, minus the gray square, that's 181 square root, take the square. Alright, and then we subtract 2 times yellow and pink. Alright, so we can get cosine PFQ, and let me see what the answer. It is 56 over 65. Alright, now but don't jump to conclusion so that the answer is 56 over 65, right? Now if you do this, it's a very terrible mistake, right? You spend all the time here only to get the wrong answer, because 56 over 65 is indeed an answer, but it is not sine angle PFQ, it is cosine angle PFQ, right? So we should do the sine and cosine conversion. We know that the sine feature is 1 minus cosine square feature, right? Sine square feature is 1 minus cosine square feature, take the square root, alright? So will you put the 56 over 65 into the cosine, and then you get the answer is 33 over 65. It's such a pretty for those who chose B, alright? You get everything correct, you spend all the time only to answer the wrong question right. Alright, the correct answer should be 33 over 65. Alright, so this is the first question. Alright, the answer is not important. Most important is the way that we construct the thinking, right? I use a lot of different colors to try to indicate the lines, and we break down the three-dimensional objects into triangles. In this case, if you look at the bottom, there's a plethora of right angle triangles, all with different colors. If you can think in terms of colors, it is much faster than those vertices A, B, C, P, Q, M, whatever. Alright. Alright, I hope you get it. I hope you can get it. That this is how we plan the procedure in the three-dimensional problems. Alright. So next, let's look at one more example. Okay. Now, it's a much simpler diagram, right? It shows a regular tetrahedron. Now, once again, a single word encapsulates a lot of idea. Regular, what does that mean? Regular means that all these red lines, they are the same. Alright, regular means all these lines, they are the same. They are all equilateral triangles. Alright, even though the line at the back is also the same. The length, they are the same. Alright, And also, all these angles between the lines, they are all 60 degrees. All right. I don't know how useful it is, but that is encapsulated in the word regular. All right? All the angles you see here, these are all 60 degrees. All right. All right. When you draw the three-dimensional diagram, it's important that you think in three-dimensional. Now, usually, if I tell you the case, then it's quite a confusing point. A lot of the students, they were making mistake here. If I tell you this angle is 60 degrees and this angle is 60 degrees, all right? I mean the purple angle and the yellow angle, they are all 60 degrees, all right? So do you have any idea about the orange angle? All right, this orange angle, what is the orange angle? Now, most people will say the orange angle is 120 because it is 60 plus 60. All right, but now that is true. That is not incorrect. That is exactly true. The orange angle, indeed, is 120. But when you put things in a three-dimensional perspective, all right, okay, so it's not two-dimensional, but a three-dimensional item. All right. So what is this purple 60 plus the yellow 60? The answer is they cannot be added together because the yellow angle and the purple angle, if it is a three-dimensional tetrahedron, they do not lie on the same surface. All right, it's just like if you have the 3 and then you have the 4. All right, you have another 3, so altogether it goes to 6. Right, that is the one-dimensional thing. But now if it becomes two-dimensional, the 3 and the 3 here. So what is the orange one? Right, you have no idea, because it goes to two-dimensional, right? You cannot just add 3 to 3. Now, similarly, like this, if the angles, they are arranged in three-dimensional sense, all right? The 60 degrees yellow actually is on the ground. It's on the ground level, right? But the purple 60 degree is kind of upright. It's standing upright at the back, all right? But if you want to ask about the orange angle, the orange angle is entirely different. Right, the orange angle lives on another surface. This plane is going kind of on the left-hand side, going to the right-hand side. The purple angle is on the back. The yellow angle is on the ground. They do not lie on the same plane. All right, the yellow, the purple, the orange, they are not flattened. It is a three-dimensional diagram. All right, so you cannot apply two-dimensional sense into three-dimensional diagrams. All right. So let me repeat the picture here. In a two-dimensional sense, all right, the purple one is 30, for example. The yellow one is 20, all right. So how about the orange one? The orange one will therefore be 50. It is okay, all right. However, if you change into a three-dimensional diagram, all right, if it is three-dimensional, the purple angle is 30. The yellow angle is 20, right? It does not mean that the orange angle is 30 plus 20. This is wrong, all right? If it is a three-dimensional diagram. So pay particular attention to this one, all right? All right, so much about this. Let's go back to this question. It wants to find the angle between the plane ABC. So this is the plane ABC, all right? And the plane BCD, where is BCD? BCD is on the ground level. BCD is on the ground level, all right? Now, to find the angle between two planes, first of all, we need to find the line of intersection, all right? It's utmost important to find the line of intersection. In this case, the line of intersection will be this blue line, all right? Let me change it to solid color. The blue line is the line of intersection between ABC and BCD. Do I get it right? It is the line of intersection between ABC and BCD. All right. Now, and then along the line of intersection, we draw perpendiculars. We draw the perpendicular from BC, all right, all the way to A. All right. So this is perpendicular. At the same time, we draw another perpendicular line from the blue line. I draw perpendicular to the blue, but that is on another plane. This one is also perpendicular, all right, but that is on the ground level. So the angle between the green line is the required angle. This is the angle between the two planes. Alright, this is the angle between two planes. We find a common line, and then we draw perpendicular to the common line along each plane. Along ABC, we draw the green line that is perpendicular to the blue. Along BCD, we draw another perpendicular line that is perpendicular to the blue. Now, because the two triangles, they are the same. ABC and BCD, they are the same. So naturally, the two green lines, they are the same. So we can get the green line, first of all. Alright, we can get the green line. The green line will be the middle line, alright? Splitting the equilateral triangle. So suppose the length of the equilateral triangle is 2, alright? Now you can use 1, but you will have 1 over 2. I can avoid the fractions by taking 2 on both sides, right? So right away we have the green line. The length of the green line will be square root 5 in it's square root 3 in Pythagoras theorem. Alright? And then the other green line is also square root 3 by symmetry. So now we have the red line and the green line. We have the red line is AD. We have the two green lines here. And the angle between the planes is this angle. Alright, so we have the root 3 and root 3. We have the 2 here, right? Remember, I take each red line to be 2 units. So you can invoke the triple S cosine formula to find theta. We have cosine theta will be 3 plus 3 minus 4 divided by twice root 3 times root 3, right? So that is cosine theta. So we have theta equals to 70.52, and that rounds off to 71 degrees. Alright, so the answer goes to D, 71 degrees. Okay, so that's about how to find the angle between two planes. Alright, we need to draw the perpendiculars. We need to find a common line between the two planes, alright? And then we draw perpendicular along each plane to the common line. Alright, so the angle between the planes is the angle between these two perpendicular lines. Alright, so that is this part of the video. We'll have some more questions in the next part.